All right, here's your review homework. So can you simplify each thing that you see? So the first thing that I see to simplify, sure, on the right page here, is the square root of 192. So I have to think, what perfect square goes into 192 evenly? So I can rewrite 192 as 64 times 3. And then the 9 I can write as 8 nm. And n squared is fine. So I get the square root of 64, which is 8. 8 times 7 is 56. 3 will be left behind. The square root of 8 as an exponent, you divide it by 2. Square root of 2 is 1, so you have 1 n. And then what's left behind is a 3 and an m. Here, cube root, what number is a perfect cube to simplify it? So the number that goes into it evenly is negative 27 times 5. X, the sixth, is good because 3 goes into 6 evenly. 13 I'm going to write as y, 12, and y because 3 goes into 12 evenly. So the cube root of negative 27 is negative 3. 6 divided by 3 is x squared. 12 divided by 3 is y to the fourth, and then write down what's left. That would be 5 and a y. All right, fourth root of 1,250. So we're going to use 625 times 2. A to the seventh, we're going to write as A4 and then A3. B to the 24 is perfect because 4 goes in it evenly. So fourth root of 625 is 5. 2 is left behind. 4 divided by 4 is just A. A cubed is left behind. 24 divided by 4 is 6. And then what's left behind I write down. So that's 2, A cubed, and that's it. Number 4, can you subtract? So the rule to adding and subtracting is that the radicals have to be like radicals. But the only way we can know that is if we simplify it first. So 27 is 9 times 3. 18 is 9 times 2. And 72 is 36 times 2. So we'll start there. The square root of 9 is 3 times 2 in front is negative 6. Root 3. Square root of 9 is 3 and it's root 2. Square root of 36 is 6 times 3 is 18. And now I can see which are the like radicals. So just the root 2. So negative 6 root 3 is fine. Negative 3 plus 18 is 15 root 2. And it's over. Here, the fourth root of 405. So what perfect fourth can you use? And it's 81 times 5. Here, the fourth root 8 with the fourth root here would be 16 times 5. And then here, the cube root of 192, that's 64 times 3, so that I can simplify it. So the fourth root of 81 is 3 times 2 is 6. And we have the fourth root of 5. Here, the fourth root of 16 is 2 times negative 3 is negative 6, and it's the fourth root of 5. And here we have a cube root, so there's no way they're going to be like roots. What number's in front? So the cube root of 64 is 4. That's in front, and then what's left behind is 3. So 6 take away 6 means they eliminate, and then that's your answer. So it's negative 4 and the cube root of 3 is your answer when you combine like terms. Number 6, root 6 is prime. Square root of 8 is 4 times 2, so square root of 4 is 2 times the 6 in front is 12, and that's it. Oh, we're multiplying them together, so that's not it. So if you multiply it together then, negative times a negative is positive 36, and then 6 times 2 is root 12, so that can be reduced down. So 12 is 4 times 3, so the square root of 4 is 2 times 36 is 72. So it's 72 root 3. Multiplying. So this is multiplied then. So 5 times 2 is 10. Negative times 36, that's 9108. negative 108. And then add the exponents, so it's w to the 5. Negative 108 can be written as negative 27 times 4. W to the 5 can be written as w cubed and then w squared. This way I can simplify it. So the cube root of negative 27 is negative 3 times 10 is negative 30. The cube root of w cubed is just w, and then what's left over. So that's 4 in w squared. Number 8, we're going to distribute. So 2 will be in front, but I'm going to go 15 times 6, so that's 90. And then distribute again, then 7 is in front, but 5 times 15 is 75. And then 90 is 9 times 10. 75 is 25 times 3. So the square root of 9, 3 times 2 is 6 root 10. Square root of 25 is 5 times the negative 7 is negative 35. These are unlike radicals, so that's all you can do. Here we're going to have to FOIL. So we're going to go first times first, so that's 12. And root 3 times root 3 is just 3, so it's 12 times 3. First times outer, that's 5 times 3 is 15 root 3. Inner is negative 8 root 3, and then last times last is negative 10. So 36 take away 10 is 26, and 15 take away 8 is 7. And you have your answer. Again, for number 10, you're going to FOIL. So 1 times 1, 1 times this and that. Notice they're going to cross out. So 1 times and 1 times, you get negative 7 root 2 and plus 7 root 2. So they're going to cross out. And then last times last, we got to be careful. That's 49 and 2. So when I put this together, that's negative 98. And then 1 take away 98 is negative 97. Here I'm squaring, so think of this, it's repeated. So 5 times 5 is 25, then the insides, 5 times root 12 and 5 times root 12, and then root times root 12 is 12. Combine like terms, so 12 and 25 is 37, 5 and 5 is 10 root 12. Now, root 12 is 4 times 3. So the square root of 4 is 2 times the 10 is 20 root 3. All right, 2 more here. Oh, and then we'll get to turn the page. All right, 12. Divide, and you get negative 4. Divide, and 5 goes into there 63 times. The square root of 63 is 9 times 7. Square root of 9 is 3 times the 4 is negative 12 root 7. Divide or simplify. 3 goes into both evenly. That's 4 over 9, and then the square root of 4 and the square root of 9, and you get 2/3. Turn the page. Eight divided by 4 is 2. And then the cube roots we divide underneath, so 144 divided by 3, that's 48. Subtract the exponents, and that's 8 to the 10. The cube root of 48, I can write that as 8 times 6. And then 8 to the 10 I can write as 8 to the 9 times a. So that the cube root of 8 is 2, and times 2 in front is 4. 6 gets left behind. The cube root of 9, you divide it. So 9 divided by 3 is a cubed, and a gets left behind. So what's left behind is 6 and an a. 15, 5 and 4, that's just going to be a fraction. And then the fourth root, 2 divided by that is going to be 1 over 81. So the fourth root of 1 is 1, and the fourth root of 81 is 3. So when you multiply it across, it's 5/12. 16. 6, reduce the fraction down. 2 goes into both evenly, so it's 10 over 9. So what I'm left with is 6 root 10 over 3, because the square root of 9 is 3, and then 6 divided by 3 leaves me a 10 root 10, 2 root 10. Here we're just going to multiply by the radical, root 6 in the denominator to rationalize it, and then we're going to distribute. So it's 4 root 6 plus 6. This is root 6 times root 6, which is 6, times 3, which is 18. 2 goes in everything evenly, so I can write as 2 root 6 plus 3 over 9. Number 18. This needs the conjugate because we have a binomial number in the denominator, so the conjugate's 4 subtract root 5. So the numerator is going to be 28 minus 7 root 5. Make sure you distribute. The denominator is going to be a difference of squares like things. So we just need first times first and last times last, and then simplify it. So we have 28 minus 7 root 5 all over 11. Number 19, again we have a binomial number underneath, so I need the conjugate. So the numerator I'm going to have to FOIL, so first times first is 4, and then outer is 2 root 2, and then inside is 5 times 2 is 10 root 2, and then last times last is root 2 times 5, so that's 2 times 5, which is 10. The denominator, 2 times 2 is 4, negative root 2, and root 2 is negative 2. So let's combine like terms. So in the numerator I have 14, and then I have 12 root 2. In the denominator I have 2. 2 goes in everything evenly, so I have 7 plus 6 root 2. I think in the answer key it says negative 2 in the denominator, but it doesn't mean it. So 4 take away 2 is positive 2. So the answer is definitely, this answer is being positive. Number 20. 5 times 2 is 10, and then add the exponent. So I need common denominators. So 3 I'm going to write as 6 divided by 2, so that the denominators are the same, and then I add them. So that's 7 over 2. So that's 10, and it's the square root of r to the 7th. So we can write that as the square root of r to the 6th times 7, and the square root of r to the 6th is r cubed divided by 2, and what's left over is just the square root of r. For 21, again, when we multiply, we want the denominators to be the same, so I'm going to write that as 3 over 3. So the base is the same, and then add the exponents, and you get 5 over 3. So that's 3v to the 5, and it's the cube root of that. So I can take out 3v's, and then what's left over is 3v squared. So this means the same as 3v to the 3 and 3v to the 2. And you can simplify it like that. In the thing it has 9v squared, so you could write that as 9v squared, and it's the same thing. All right. When you divide, you subtract the exponents. The denominators are the same, so it's 2 over 4. So that's the same as the square root of 9, square root of n. 23. We have 243x to the 5th to the 4, and it's the 5th root of that. So the 5th root of this, there is a number 5 times itself, that's 243. That's 3. So instead, we can do the 5th root of 243x to the fifth, and then to the power of 4. Both are correct. Whichever way allows you to simplify it. Here, it's 3, and x to the fifth, that's just x, because they divide, and then to the fourth. So then 3 to the fourth gives you 81x to the fourth. Here, the bases are the same, so you can, well, first we're going to multiply the powers together. So that's 5 over 6. Then in the denominator, I'm going to create common denominators. So I'm going to write it as 3 over 6. And then I'm going to subtract. So when I subtract exponents, I get 2/6. That's the cube root of 54. And that can be written as 27 times 2. And the cube root of 27 is 3. And what's left over is the cube root of 2. 25. The negative exponent means reciprocal. And then it's the fourth root of that. So I'm going to reduce the fraction down. 9 goes into there evenly. So that's 16 over 1. And then when I do the reciprocal, it'll end by 1 over 16. And it's the fourth root of that. So the fourth root of 1 is 1, and the fourth root of 16 is 2. So it's 1/2. 26, when I multiply it, I need to get common bases for the exponents. So 4 times 3 is 12. I'm going to change this to 4 over 4. So when I add it, it's 9 over 4. So if I write this, that would be the fourth root of p to the 9, but I'm going to write as p to the 8 and then p. So 8 divided by 4 is p squared, and then what's left over is just p, and it's the fourth root. Here we need common denominators for the, so we write it as an exponent, 1/3. Then I need common denominators times 3. So I have 6 over 3 and 1 over 3. So when I subtract, I get 5 over 3. So that's the cube root of m3, like m to the 5, but I'm going to write it as m cubed times m squared. So when I do the cube root of the exponent, it's 1m, and what's left over is the cube root of m squared. All right, last one, practicing how to simplify radicals. So 49 can be written as, and then y to the 22. So let's just, we could write this as 7 squared, and we could write this as y to the 11 squared, so that, because 11 times 2 is 22, so that when I do the fourth root, it will make it the square root of 7 and the square root of y to the 11th, and then I can write 11 as 10 and 1y, and so the square root of y to the 10th divide by 2 is y to the 5th, and then what's left over is the square root of 7y. All right, reviewing radicals, how to simplify radicals. Good job reviewing with me. Mr. G Math, over now.